All right, let's talk about one of the most common coding interview questions out there. But we're not just going to solve it. Oh no, we are going to turn this thing into your secret weapon, a chance to show that you don't just know an answer, you actually understand the strategy behind it.
So picture this. You're in the hot seat. The interviewer leans in and says, "Generate the Fibonacci series." Now it sounds simple, right? Kind of like a warm-up. But trust me, how you answer this can reveal way more than you think. It's a test of your efficiency, your clarity, and really, your strategic thinking.
Okay, so first things first, what are we even building here? The Fibonacci series is a total classic. It always starts with 0 and 1, and from there, every single number is just the sum of the two that came before it. So, 0 plus 1 is 1, then 1 plus 1 is 2, 1 plus 2 is 3, and on it goes. Simple idea, but there are a few very different ways to get there.
Your first and, honestly, your best move is to start with the most solid and efficient approach out there. Iteration. Think of this as your foundation. It shows the interviewer right off the bat that you can deliver a practical solution that just works.
The logic behind this is just, well, it's beautifully simple. You kick things off with two variables, a 0 and a 1. Then you fire up a loop. Inside that loop, you calculate the next number, you shuffle your variables to get ready for the next round, and you just repeat. It's a clean, step-by-step process.
And here's what that logic looks like in Java. The real beauty here is just how straightforward it is. See those three lines inside the loop? That's the entire engine. You calculate, you update, and you're done. It's clean, super easy to read, and it is lightning fast.
And would you look at that? It works perfectly. It spits out the exact sequence we wanted. So, problem solved, job done, right? Well, not if you're trying to really knock their socks off.
So, what else have we got? Well, the next stop on our tour is recursion. Now, a lot of developers go for this one because it feels so elegant, It's like a direct translation of the math. But as we're about to see, that elegance, it's a trap. The whole idea is kind of neat. To find the Fibonacci number for, say, n, you just add the Fibonacci of n minus 1 and n minus 2. The function basically keeps calling itself with smaller and smaller numbers until it hits rock bottom, the base case of 0 or 1, and then all those results come bubbling back up.
And, you can see the appeal, right? The code is incredibly short. That one single line perfectly captures the mathematical definition. It's beautiful in its own way.
And again, it works. It gives us the right answer. So now you've got two working solutions. The first one, iteration, is a little longer. This recursive one is shorter, looks kind of fancy and academic. And this, right here, is the moment in the interview where you get to shine. This is where you separate yourself from the pack. You've just shown two perfectly good ways to solve the problem. But now you have to show that you understand the consequences of your choices. What's the hidden price you pay for that super elegant recursive code? And here it is, the catch. To calculate a higher number, that recursive function ends up calculating the same exact values over and over and over again. All of that repeated work just explodes into a massive number of operations. It's an elegant idea that, in practice, is just wildly inefficient.
This is where you bring out the big guns. This is the pro move, dynamic programming. It's awesome because it kind of takes the best of both worlds. It has that clear logic from the math formula, but it brings the efficiency of iteration by using a little something called memory.
So here's the secret sauce. Instead of recalculating values all the time, we just store them. We make an array, we pop 0 and 1 in the first two slots, and then we loop. But here's the key. To find the next number, we just look up the two previous results we already saved in our array, add them up, and store the new result. 0 repeated work. It's beautiful.
And the code shows this perfectly. We create what's called a DP array, that's for dynamic programming, and the heart of our loop is just grabbing the last two numbers from the array and adding them. We are literally building the series one step at a time, using our stored results. And of course, it gives us the correct output. So now we've shown three different ways to solve the problem, and we ended up with a solution that's not only clear, but also super performant. That's the whole journey.
Okay, so how do you actually use all of this in an interview? Because it's not just about slamming down code, it's about telling the story and showing your thought process. Let's walk through the playbook. Think of this table as your cheat sheet. When an interviewer sees the iterative solution, they think, okay, solid, reliable engineer. When you talk about recursion, they think, they understand the theory. But then, when you bring up dynamic programming, they think, wow, this person actually thinks about optimization. Being able to explain these trade-offs is the real goal here.
So here's your winning script. Step 1. Start with the iterative solution. Get a good, solid working answer on the board. Step 2. Mention recursion as another way to do it, but immediately, and this is key, point out its big performance problem. And finally, Step 3. Propose dynamic programming as the optimized fix. That narrative arc shows you're a thoughtful, well-rounded engineer.
You see? By following this strategy, you take what seems like a basic warm-up question and you turn it into a total showcase of your skills. You're not just solving a problem, you're demonstrating a deep understanding of efficiency, trade-offs, and optimization. So are you ready to make this simple problem your biggest strength in your next interview?